the boy has a weight of 60 pounds. As you can see, the weight of this boy is, so it is acting downward, agreed? And the weight is downward, has 60 pounds. So I would say this is an FPS system, and at that instant a picture has been taken at an angle of 60 degree. Okay, the boy's center of mass is G, experiences the velocity V, which is 15 feet per second. So if I draw, this is the motion, which is this is motion, a tangent unit vector, and the normal unit vector is directed towards the center of curvature. So I would say this is the normal unit vector, this is the tangent unit vector, and the question is find the tension in the cable. There are two cables supporting the body weight, so it will be 2 times tension. Anything else? So they want us to find out the tension in each cord, plus they want us to find out the rate of increase in the velocity or the speed. The rate of increase in the speed is known as the acceleration. If this is speed, so it's a tangential acceleration which they want us to find out. So let's do the math. As all the forces along the normal, their mass times acceleration normal, all the forces along the tangential unit vector. So let's use the Newton's second law to solve this question. So if I were you, I would resolve the all forces. There are just two forces, okay? 2 times T in one force. I would say T is in one chord, T is another chord, so there are actually 3 forces. 2 times tension is, there are 2 forces, and W is acting downward. Can you resolve? So if I change the color here to show you the resolved unit vectors, let me change the, so if I want to resolve this weight along the normal, along the tangential component, so then you can see, you can take a look. If you see, this is 60 degree, this is 30 degree. Do you agree with me? If this is 30 degree, this is 30 degree, and what is this component? W sine 30. And what is this component? This is W cosine 30. Do you agree with your professor? Now let's do this, all the forces along the normal. So normal is directed towards the center of curvature. So I would say 2 times T is positive. I would say this is normal unit vector. Agreed? And 2 times T is positive. This vector component, which is negative W cosine 30. Agreed? Equals to mass times acceleration normal. Now we do not have directly given, like it's not given directly, but you know that the acceleration normal can be found from this formula, v square over rho, which is the centripetal acceleration, and the velocity is given for this boy. It is 15 square over rho. Rho is the radius of curvature, which is 10 feet. If you closely look, this is a little blurry, it's 10 feet, so I can write down 10 here. And if you do the math, you can I can do the math for you. Look, it's about 22.5. Am I right? Let me check. So it's 22.5. So this is in feet per second square. So we are happy now. The mass is actually, if you know the weight, how do you go from weight to the mass? Exactly. And in gravity in the FPS system is, do you know? Good job. So it is the gravity. So 32.2 feet per second squares. So I can write down like this: 60 divided by 32.2 times 22.5. The right hand side. Let's do the right hand side first. And 2 times tension is unknown, W is known. W is 60 pounds cosine 30. So one equation, one unknown. If you solve for T, you should get 46.9. You can check this answer in your scientific calculators and verify. Can you verify and help your professor? You want me to bring it down? Now let's do the math. Let's complete the second equation of motion, which is along the tangential unit vector. So if you take a look, this component is along the tangent unit vector. Agreed? There is no other component acting along the tangent. So I'm going to write down the equation of motion here. So let me zoom out a little bit. So W, I would write down sigma, all the forces along the tangent, A sub t. So I would write down W sine 30, mass is 60 divided by 32.2 times acceleration t, which is unknown, 60 times. So if you do the math, you should get 16.1 feet per second square. This is your answer.